Please all participants open our studio, launch your working directory genomic batch 7 and type done. And for manually please share your screen because we have done some basic practice on your screens in our yesterday class. So please share your screen so that we can proceed from this step to next step. Okay, thank you. Now please open our studio. Please open our studio. Okay, thank you. Now please run your previous lines so that your data loaded. Scroll up. Yes, from here. First to library. Next line. Next line. Next line. Next line. Okay. I think it's showing you red dot, so you need to wait until this red dot disappear. And all participant, please, hopefully you have watched previous video and have done this step. If not, please formally share these codes within group or within Zoom chat so that other participant can also run these steps and import these files into your screen number 3. Okay, now your all codes are successfully done. So just copy and paste in your Zoom chat so that all participants can use these scripts. And if you can generate your own script, you can also generate. Please share within Zoom chat. Okay, thank you. Now please come to new line. Okay, now copy these codes and come to ChatGPT. Now come to ChatGPT. Show me ChatGPT. You can open your previous DNAseq analysis page, yes, and write a message here. Thanks. I have done these steps successfully. And paste your copied script here. And write a message. No, I want to perform next step. Please give me script for next step one by one. Please copy all and paste. You have in your previous script you have typed correct sentence and paste here. No, write a message. Oh, okay. Perfect. You have successfully finished quality control filtering step for your E. coli dataset. Now the next logic steps after what you done are alignment of read to reference genome. Now next step is after quality control, you need to perform alignment. So for alignment, you need a reference genome. So since you already downloaded the reference genome, you can align read against it. Usually in R, we don't align directly. We call external aligners like BWA or bow tie 2, then import BEM files back into R. So here is the script, but it is I think not an R script. Paste here and run. It is not an R script. It is a boy script. Come to your previous, come to ChatGPT and write a message. It's showing you outside R command line. Scroll up, please scroll up. Scroll up, please. Show me, yes. It's showing you need, no, please, alignment step. Scroll up, not down. Your first step, yes. Alignment for read to reference genome. It is showing you, usually in R, we don't align directly. We call it external aligners like BWA or bow tie 2. Okay, now come to chat and write a message. Is there any tool in R for alignment of read to reference genome? For alignment of reads to reference genome? It's showing I understand you want to align two reference genomes, not read to our reference. That's whole genome alignment, which is different from the read mapping. Yes, there are tools in R for this, though for large genome people usually use specialized software outside R. Here is the R-based projects. Okay, no, but there are two genomes. We only have one genomes. So write a message. I want to align genome with reference genome with the reference, not to reference, and send message. It is showing you got it. No, you mean align your DNA-seq read to reference genome, not comparing two reference. That's the standard read mapping step. In R, there is not a fast native aligner for large genomes like E. coli. Usually, people use external tools like BWA or Bowtie2 or Minimap2, then import the alignment back into R for analysis. No, there is a guidelines how to use, how to convert in BWO. So, no, you need to write another script to ChatGPT. Copy this BW, no, please scroll up. Copy this sentence. There is not a fast native aligner. Copy these two lines and paste in below line, new script line or chat line, and write a message as there is not a type as at start. At start. Okay, now after analysis add how I use these tools. How I use any one tool for DNS for reference genome for alignment. Use these tools for alignment. Please guide me step by step and send this message to ChatGPT. Asanul, Asanul Islam, you have two files in your working directory. So these are the two files. One file for forward sequence, and other is reverse sequence, and other is for reference genome. You have three files in your working directory. Use these files. Okay, now scroll up. Come first read paragraph. It's showing you absolutely. Let's go step by step for aligning your paired and equal reads to a reference genome using BW, Bowtie, or Minimap. I will focus on BW first, since it's widely used and very reliable for bacterial genomes. I will also show how to bring results back into R. So first is install tool, but you need BWO. So you need a Linux or other tool. So write a message here. Again, write a message. I am not familiar with BW, Linux, Ubuntu. Please guide me step by step so that I can perform this task. I just have window and R. Okay, send this message again. It's showing you perfect. Thanks for clarifying. Since you are on window and R, we can do the whole pipeline with window-friendly tools, still using R to call them. Here is the step-by-step workflow for aligning your E. coli paired and reads to the reference genome. We will use BWA for window and smart tool and call them from R via system. Step number 1, install required software. So first click on download Windows zip file. Yes, click here, open website. After downloading, there is a extract and executed will be like exe file. You also need to install smart tool for window. Also open this website. Smart tool. Please download Smart Tool. Please, yes. And save in your working directory folder. Also download second tool. Yes, download latest version. Click on download latest version. Okay, scroll back. Please click on back. Yes. Here is BW. Please show me ChatGPT, which is the latest tool name. It is showing you Windows, zip, and BW. Okay. Now again come to website and scroll down and check the latest version. Scroll down, scroll down more. You can search date wise. Please, and search date wise. Yes. So latest is released on 2017. So open this, download this BW07. Wait. Yes, it's start downloading. I think download it. Okay, now copy these folders and save in your working directory. Please, yes, both save both tools in your working directory folder. Yes, paste it. Now extract both files. Click on show more option. Yes, extract. Okay, come back and extract second files, smart same tools. Okay, now come back to ChatGPT. Now after downloading, add both folder to your window path. Optional, but make calling series easier. Okay, now index your reference genome. Set path to executable and files. You need to define your path. Okay, copy the script. Open R. Paste here. Yes, paste here. No, you need to edit your script because your files are in working directory. Please open your working directory. DNAseq data. No, no, not from here. From screen number 4. DNAseq data. Here you have two files. One is extracted. Smart tool is also extracted file here. No, you need to replace address. Your file name is bwa dot 0717 dot tar dot bz2, but here it is showing you xc file. No, come to your main folder. Please come to your main folder. Come to BWA. Open BWA. Please open BWA folder. First folder. Your first folder is BWA. Again open. There will be a exe file. Open BW kit. If not here, and check here exe file. There is no any exe file here. Okay. Now again come to ChatGPT. Write a message. Can R directly download? Download these required tools and save in working directory folder. Add question mark and send. Yes, R can download the required files or even BWA or smart tool directly into your working directory, and here is. Okay, find the script for scroll down, not this one. Please scroll down. Yes, this one. You need no. Scroll down more. Download BWA and smart tool. Yes, you need this one. But before this, you need to install a package. If you scroll up, there is a package. Scroll up. Add yes, install dot packages are utils. Copy and first install this tool and wait. Okay, now come to ChatGPT. Scroll down and no, not this one. Download BWA script. Yes, here is the BWA script. Copy, paste here, and run these one by one. Next. But it's showing you an error. Cannot open URL. Okay, copy this error. Provide to ChatGPT. No, scroll down up, come to second option. Yes, use this one. Okay, next. But it is again showing you an error. Okay. No, let me try on my own screen. For Manli, no, I'm sharing my screen. Here is batch DNAseq batch. Okay, in our previous class, I also have done these steps. No, I will revise these steps and one by one. All steps are working. No, I will copy these steps. Open ChatGPT and will use GPT's R tutor or studio R and R studio. I will write a message here. I have done. I have done these steps. No, I want to frame low quality reads which are less than 20 in R. It will give me script to remove low quality reads. So here is a very simple step. Copy and I will paste here and run. First step, library. Second, third option, and write FASTQ files again. After trimming, it will give me another new data set, but it is showing me an error. 20 must be a character with encoding 128. So I will copy this, will provide to ChatGPT and will reply me. Here is the correct code. Copy. Here is the corrected code, complete corrected code. And here is if we want to inspect quality before and after. Copy R, paste here, and I will run it again. But again showing me an error. User argument mismatch. 20 must be a character with encoding 128. It means I need to again copy and I will provide to ChatGPT. It's showing me look like everything runs successfully up to writing of the first trimmed FASTQ files. No errors shown. We love to see it. No. Before we move forward, here is a quick checklist to wrap up the trimming step properly. First step, you probably just forget this line. I also need to run this line. Copy. Make sure to run that to save the second trim files, and then optional inspect resulting read set and want to quality report after trimming. Okay, now next step is it's working and I have results SRR1 trimmed FastQ files and trimmed FastQ GZ file, second file. But I need to wait until this red dot disappear and then I will check quality before and after. Quality after trimming. Copy, paste here. It is showing me exist, but mode is not A. Okay, so file is found here because I already have filed this, so it's not copying second file here. I will run this for quality. It is again showing me lane must be character 1. I will copy these lines because ChatGPT not have my data set, that's why it's showing me errors. If I give its proper data structure, then it will give me exact code. So yes, you are running into a classic pitfall when using QA from short reads on an in-memory short read queue objects. So this function only work on file path, not directly on short queue reads objects. So I already have these files in working directory. If you have path, then this script will work. If you don't have path, then you need this script because my all data is found in working directory, so I don't need any path. Okay, now I have uh, performed quality control after trimming for file number 1 and file number 2. No, I will write a message here. Thanks. No, I want to align these reads with reference genome in R and will send message. It's showing me perfect. Know that you are cleaned and quality trimmed your paired and reads. The next step is align them into your reference genome using R. First, we need this file. Recommendation in R alignment tools, R subread. The R subread package is a powerful and fast aligner available directly in R and perfect for this. And no, you can check in your sites. ChatGPT giving you R don't have package because you are using free version and in free versions, not all informations are up to date. But with the passage of times, R is updating day by day. No strongest package is available in R for alignment, which is known as R subread. So first I will run this code to import this file. Yes, this file is working. And a file is created in screen number 3, reference genome. Now next step is step overview. Install load R subread, build genome index from your FASTA reference and run align on paired and reads. So here is the full R code. Here is the optional code. So first I will run this code, copy, open R and will. So for this we need R subread. I think I already have this package. So try to do library. Yes, I already have this package. So it's showing me done. Next step, build genome index. Only needs to be done once. Don't run it for multiple times, just once. Step number one, build genome index. First, we need to create genome index. No, second step is align paired and read to reference genome. No, I will run second step. It will align paired ends reads to reference genome. So first, base name of index, forward reads, reverse read, compressed fast queue input, output file adjusted for your CPU and confirm encoding. So after this, it will give me another file in my working directory, compressed fast queue, sorry, output file. But it's showing me an error. Two input files have different amount of reads, and two input files have different amount of reads because we have trimmed some reads. If you notice in filtered, you can check reads are different now. Filtered reads are 497 and in first file is 769. So reads should be same. I will copy this all steps so that I show to ChatGPT I have trimmed some genes or reads. It's showing me you have hit a common and critical issues in paired and alignment. Two input files have different amount of reads. This means your two trimmed files and no longer have the same number of reads because we have removed reads from second file. In our previous class or yesterday class, we have checked quality control. First file have all reads above 20, but second file have few reads below 20, and we have removed reads which are below 20 from second files. So why this happens? After trimming with and filtering with, you filtered each files independently, so a read in one file could be discarded while its mat is kept in the other. So we have deleted reads from one file while other files reads are present. So we also need to match, or we also need to remove those reads from file number one also. So here is its solution. We need to run these codes again to make sure all reads in both files are equal. I will run it again. Okay, now copy next step, align again, copy R, and I will paste here and run. Now showing me check the input reads, but red dot appeared, so I need to wait. Uh, Sanul Islam, I need to check your screen. to debug this issue. While it's working, please share your screen. While it's showing me red dot, you can share your screen. Okay, you don't have data set. Okay, Sanal Islam, you need to watch your Thursday video. In our last week video, we have downloaded data successfully. Okay, I am going to send data within group so you can use it. And you can also watch video how to download DNA sequencing and reference genome from website. I am sending data file, please check. I have sent in group. It's a big file, may take time. I have sent in group, please check. It's taking time. One file is about 4 MB, maybe you get within seconds, but other files are in MBs more than 150 or 175 or 182 MB, so may take few minutes. So files are big and it may take time for alignment. We need to wait. I am sharing these lines with you so that you can do within R. Please Farman copy these codes and run on your screen also. We need to wait until this red dot disappears. For alignment, it will take time or even days because depending on your data set and power of your laptop or PC, it will take up to 1 hour, 2 hour, 3 hour. So I can confirm from ChatGPT for equali how much time required. I will write a message here. I have so much time required for alignment. I will give screenshot for reference. and will send message. It is showing me great question. Based on your screenshot and current setup, let's estimate how much time alignment will take using this tool. First, what we know your environment and trimmed FASTQ files have 1.5 million reads each, and each file is 600 MB in memory. So expect 1 to 1.3 GB total. System resources, you are using RStudio on Windows. 4 threads are enabled and likely running on a personal desktop laptop. And here is the estimate. Estimate time is 1 to 3 minutes. You can monitor completion percentage. I have 32 GB RAM. Then how much time required? So it's showing me your issue is not RAM. Maybe your issue is file corruption, or maybe issue in your data. So let's wait and check. Please you also run these lines within your R environment and let me know how much time are showing you red dot error sign or you have done easily. Yes, it's showing me. We need to wait the time estimate based on the real benchmark. 1 MB read, 2 M read, we have 1.5 million reads between 2, 4.6 MB, 6 threads, and will take 1 to 5 minutes, but many minutes have passed. Okay, don't worry, wait. And after this step, you will get another file with BAM file format. Your file name will be aligned read.bam in your working directory. In my side, I have generated 2 files. First is the reference index. Here is the reference index. When I run this script, step number 1, it gives me a reference index file. And then I apply further analysis. Now you can check in line number 182. No, I used reference index instead of my reference file. So no, reference index will be converted into these 2 files, with these 2 files into aligned read.bam file. After this, you will get a single file. Now we will proceed with BAM file for further downstream analysis. Okay. Now please apply and wait. When I complete this step, I will share its results with you within group as in a screenshot, or we will discuss in our tomorrow class with further detail. So in our previous class, we have applied quality check. After quality check, you need to trim. We have applied trim, but unfortunately or mistakenly, we have trimmed only one file. So a mismatch between file number 1 and file number 2, we need to make sure data or reads within both files should be equal. So when you get, for example, in our previous class, we get two plot, one plot and first plot and second plot. First plot is for file number 1, second for file number 2. In first file, our reads are mostly above or near to 30 or maybe touch to 30. But in second file, our reads are below 20. Few reads are below 20. So we need to trim these reads. If you want to make sure all reads should be equal, if you can trim instead of 20, if you trim at 30 where both reads are same, you can trim here. For example, here is the 30 and at 30 all reads are same. I will trim at 30 so that all reads numbers will be same in both files. So instead of trimming 20, if you choose 30, it will be best. I will show you plot, then hopefully it will be more clear. Here is the plot, quality report read 1. Here is the quality control of read 1. Now you can check in read 1. The quality score is above 20 in read 1. Here is, I think 26 or 27. If I open second file, now here is the second file. In second file, you can check reads are less than 20. So we need to remove these reads. If I remove from here less than 20, many reads are between 20 and 30 like this. So number of reads will be disturbed if I trim from here. But if I trim from 30 and also trim this file from 30, I will trim both files at 30. At 30, no. These removes, all remove, for example, above 30, there are 50 reads. For example, we have 75 reads. Here we also have 75 reads total, for example. And 50 reads are above the 30. 15 reads are between 20 and 30. And 10 reads are below 20. And if I come to this site, maximum reads are in between 40 and 30, but few reads are found here. For example, between 30 and 20. For example, there are 10 reads. And remaining 65 reads are between 40 and 30. If I trim both files at 20, these 10 removed, erased, but when I run same analysis on first file, there is no any read at this space or at below 20. So total number of reads will be 75 after trimming, and in this file, after trimming, total reads will be 50 plus, here is 65. Okay, no, when I remove reads after 35, after 35, and here, sorry, after 30, here after 30, from screen number 1, 10 reads will be removed. And from file number 2, 25 reads will be removed. But remaining reads should be same because in screen number 1, we have 65 read left, while in your sorry, in your second file, you only have 50 reads. Sorry, I think I have missed calculation. Here is 10. I need to add here is 10. Here is 65. Here is because both are same on above, just difference below 30. Here is 60. For example, here are 5 and 5. Then okay. 15 removed. Sorry, 10 removed. 5 here and 5 here. When I remove from 30, 10s are found here. Are 5 here, then 70 here. For example, here is 70 and just here is 5 only. Okay, no, it's okay. Now when I remove from 30, below 30, in screen number, sorry, it's 65 is okay. So screen number 1, 5 will be trimmed, and on other side, 10 will be trimmed. It will unequal our data. So our should be 10 is correct. 65 above, 10 is here. 65 above, 10 is here. These 10s is only between one set, between 20 to 30, but these 10s are found between 20 to 30 and 30 to 10. So when you remove from one side or you remove only after 20, it will show you 70 here and 75 here. So there is a difference between 5. And if you remove after 10, after 30 and after 30, no, it will remove 10 here, remove 10 here, then your reads will be 65 from file number 1 and 65 from file number 2. Then you, okay. But if you remove unequal, it will disturb your data and you will be unable to proceed for further analysis. Okay, just let me check once. Yes, it's working now. I will wait until it completes. Okay, thank you. And in our next class, after downloading this file, we will proceed for downstream analysis. Okay, thank you and Allah Hafiz.